Today's math problem comes from the AIME 2001 math competition, and it tells us that a finite set S of distinct real numbers has the following properties, where the mean of S union with 1 is 13 less than the mean of S, and the mean of S union with 2001 is 27 more than the mean of S. And it asks us to find the mean of S. So let's go ahead and jump into this. First, I'm going to go ahead and define A to be the number of values or arguments in our big set S, and then X is going to be our mean. So this is going to be our goal here. So now we're going to use these two conditions to form some equations. So first, we know that S union with 1 is 13 less than the mean of S. So S union with 1, that mean, is going to have the value AX, that's the number of values in S times the mean of S, plus 1, so that's just all the numbers in our set S added up, plus 1, over A plus 1, that's the number of values in S originally, plus an additional 1 because we unioned with this set of just 1 by itself. And that's going to be equal to the mean of S, but it's actually going to be 13 less than the mean of S. So we'll have X, which is our mean of S, minus 13. And then we're going to do the same thing for this red dot down here. So we have AX, again, that's our total sum of all of our values in S. And then we're going to add 2001 to this one. And then again, dividing by A plus 1. And this gives us X plus 27. So now we have two equations and two unknowns. What I'm going to do first is multiply both sides of this equation by A plus 1. So we get AX plus 2001 is equal to AX plus X plus 27A plus 27. And this is from A times X. This is 1 times X. This is 27 times A and 27 times 1. But then we can simplify this a little bit. We can get rid of these AX terms because subtracting from both sides will just cancel them out. So we're left with 2001 is equal to X plus 27A plus 27. Okay, that's not too bad. And now what we can do is we can actually solve this for X and plug this into our top equation here. But what I'm going to do first is multiply this top equation by A plus 1 on both sides. So doing that gives us AX plus 1 is equal to AX minus 13A plus X minus 13. And again, these AX's cancel just like before, and we are left with an equation that is 1 is equal to X minus 13 minus 13A. Okay, so that's not too bad there. Let's clean this up, and I'll rewrite our two equations as this equation and this equation, and we'll go from there. Okay, I've cleaned this up and I've brought our two equations up, and now there's a number of different ways that we can solve this system of equations. What I'm going to do is I'm going to solve this top equation for X, plug it into this equation here, and then solve it for A, and then plug A into our original equation for X. So we have X is equal to 1 plus 13A plus 13. That's by moving these two terms across this left-hand side and then just switching their sides. And now plugging this into this equation, we get 2001 is equal to 1 plus 40A plus 40. That's 13 plus 27 and 13A plus 27A. And then subtracting both sides by 41, we get 1960 is equal to 40A. And that gives us that A is equal to 49. So we know that A is equal to 49. And we can plug this back into this equation to find our X. So we have X is equal to 1 plus 13 times 49 plus 13, which is just equal to 14 plus 13 times 49. And that's going to be equal to 651. So we found that A is equal to 49 and that X, our mean value, is equal to 651, which is our final answer for this problem. I think that's enough for now.